Hey guys, welcome to the last video in Unit 1. Today what we're talking about is parallel and perpendicular lines. So just a quick little recap. A formula that you've learned in the past when you were talking about finding slopes of lines was the slope equation, which is m equals y1 minus y2 divided by x1 minus x2. Okay, so this is the change in y divided by the change in x. You've also heard it as the rise over the run, or the difference in your y values compared to the difference in your x values. So how we use this is, just like with the distance and midpoint formula, we're going to have 2 points, just like here in A. We're going to call them x1, y1, x2, y2, and then we're just going to plug them into our formula. So m equals y1 minus y2 is negative 1 minus 7. And then we got 3 minus 4. Okay? So the top part, negative 1 minus 7 is going to be negative 8. And then 3 minus 4 is going to give us negative 1. Negative 8 divided by negative 1 gives us positive 8. Okay? Other side, exact same thing. x1, y1, x2, y2. Then we're just going to solve for the slope. So this time it's 3 minus 4 on top, and then x1, x2 is 2 minus a negative 1. The top is going to give us negative 1. Be careful with the bottom though. Remember, when you're subtracting a negative, that becomes plus a positive. So it becomes 2 plus 1, which is 3. So our slope for this one is negative 1/3. So the slope between these 2 points is negative 1/3. And the slope of the line between these two is positive 8. Now, you've definitely heard these terms before. Well, for sure, parallel. Remember that parallel lines, those are just two lines that they are going to go forever and ever, but they're never going to touch each other. The definition is lines that never intersect. And you can have more than one set of parallel lines. You could have 20, 30, 40 parallel lines all going by each other but never touching. But typically we're just going to think of this as two specific lines. And here's our visual representation. Now, if you look at the lines, one's higher than the other. The reason is because they have different y-intercepts, but their slopes are actually exactly the same. They're increasing or decreasing at the exact same rate. So if we look at this top one here, it's going up 1, 2, and then over 1. So it's got a rise of 2 and then a run of 1. So it's positive 2 for the slope. Okay? Same thing if we look at this figure here, up 2, over 1. So their slopes are the same. That's how we know two lines are parallel without actually looking at them on a coordinate grid or plotting them. Slopes are the same. Now that one's pretty easy to remember. And remember, when we're talking about slope, we are looking at the y equals mx plus b. So this, the number in front of x, the m value has to be the same. Then on the other side, we have perpendicular. Sorry, I've recorded this video a couple times, so I got some leftover drawings. Perpendicular lines, the definition of those is lines that intersect to form a specific type of angle, and they form a right angle. And remember, a right angle is a 90-degree angle. So if you look down here, here's the visual representation. It creates a right angle in every single spot, but they intersect exactly at a right angle. Now, their slopes have an interesting relationship. They are what is called opposite reciprocals. Okay, I'm going to write an example here. So you've heard the word opposite, and in this case it just means one slope is positive, one slope is negative. Reciprocals comes from, we think of a fraction. It's just the flip of the fraction. So let's say that we had positive 2/3 as the slope for 1. Well, the opposite reciprocal slope of 2/3 would one be negative, and then if you switch around 2 and 3, you get 3/2. This is an example of opposite reciprocal slopes. Okay? And we'll see some more of these as we go on. Next question says, compare the two equations in each question below. Are the two lines parallel, perpendicular, or neither? So we can have instances where they're not parallel or perpendicular. So we want to be careful with these. And then it says have some reason for our response. So we're just going to talk about the reasoning as we go. So the first letter here, A, is y equals 3x minus 7 for slope number, or for line number 1, and then y equals negative 3x plus 2 for line number 2. So what we are comparing is what's in front of the x's. Those are our slopes. So the first one is 3, and they're not exactly the same because one's negative, so it can't be parallel. But to be perpendicular, they would have to be opposite reciprocals. Now, the reciprocal of 3 is actually, if you treat it as 3/1, 1/3. So negative 3 is not the opposite reciprocal of 3. So this is an instance where we would write neither, because it doesn't meet either criteria. All right, part B, y equals positive 2/3 x plus 1, and y equals negative 3/2 x minus 5. So 2/3, I did not actually mean to do the exact example before. Positive 2/3, we change that to a negative, we flip the 2 and the 3. Those are opposite reciprocals. So this would be an example of perpendicular lines. And it doesn't matter what their y-intercept is, they're still going to meet at a right angle. So these two lines are perpendicular to each other. Now with this last one here, line MN, we have M and N, and then line AB, A and B. We have to find the slopes. We don't need to find the entire equation, like the y-intercept. Not that it would be bad to do that, we're going to do that here a little bit later on. But we need to find the slopes between these lines. So I'm going to go ahead and do my x1, y1, x2, y2. So just as a quick refresher, it's y1 minus y2 over x1 minus x2. So for the top line, our y1 is 2 minus 6, and then we have 3 minus 5. So 2 minus 6 is going to give us negative 4. Then on the bottom, 3 minus 5 is going to give us negative 2. When you take negative 4 and divide it by negative 2, you get positive 2 as the slope. So for this top line, m equals positive 2. Now we're going to go ahead and do that exact same thing, but now this is our x1, y1, this is our x2, y2. There's a lot of negatives here, so we definitely want to be careful. So y1 is 4 minus y2 is negative 2. I always like to put my negatives in parentheses when I'm adding or subtracting. Then we have our x's, so negative 1 minus negative 4. Definitely want to be careful when we're writing these in. Remember to follow this equation right here. Okay, 4 minus minus 2 gives us plus 2. So we end up getting 4 plus 2 is 6. And then the bottom, negative 1 minus a negative 4. Again, we're going to add 4, but since it's a negative 1, the answer ends up being 3. And 6 over 3 reduces down to 2. So our slope is the same for the top line and the bottom line. Therefore, we get a parallel relationship. All right, I'm going to continue on here. This one says write an equation for each line described. So it has to be parallel to y equals 3x minus 5 and passes through the point 4, 2. Okay, so if it's parallel to y equals 3x minus 5 and passes through that point, well, the fact that we know it's parallel tells us that the slope of our new line has to be 3, because parallel, it would have to be the exact same. So far we know it's y equals 3x. We don't know what the y-intercept is, so we're just going to put the plus b. Now what we want to do to find it is, remember that this is a point that it has to go through, so this is an x and y pair. So what we're going to do is we're going to take 4, plug it in for x over here. We're going to take 2, plug it in for y over here. So it becomes 2 equals 3 times 4 plus b. So 3 times 4 is 12 plus b. To get b by itself, this is like a variable. We subtract 12, and we get b equals negative 10. Okay, so we end up getting y equals 3x, because that was our original slope, which we got over here on the left. Now that we know the b value, we just plug it in as negative 10, and there's the equation of our line. Very similar setup for this next one. So what we do now, though, is since it's perpendicular, we look at the slope and we have to think about what is the opposite reciprocal of negative 2. And so negative 2 over 1 transforms to become positive 1 over 2. So positive 1/2. So far we know that the slope of this line is y equals 1/2 x. Do the exact same thing, plus b. Now we're going to use this as our points for x and y. So I'm going to take 6, plug it in for x, 7, plug it in for y. So 7 equals 1/2 times 6 plus b. I apologize, my b's kind of look like 6's. So half of 6, when you multiply those, you get 3. And then to get b by itself, we subtract 3. And we get b equals 4. So now we have everything we need. Y equals, our slope is 1/2 x, and our y-intercept is positive 4. There we go. Okay, last example here. This is like the one we did earlier, right up here where it said it gave us MN and AB. So we need to figure out, are the lines parallel, perpendicular, or neither, and then just explain our answer. So exact same thing, we're just going to set it up as x1, y1, x2, y2, and we're going to find the slopes of each of these coordinate pairs. Okay, so we got 1 minus negative 2, and then the bottom negative 3 minus negative 7. 1 minus negative 2 becomes a plus, so that's 1 plus 2, which is 3. And then down here, plus 7, because 2 negatives again. Negative 3 plus 7 gives us 4. So we have m equals 3/4 for this one right here. Now I'm going to go on to the next one. Here's my new x1, y1, x2, y2, negative 1 minus 4, 2 minus 8. Okay, so the top, negative 1 minus 4 gives us negative 5, and then the bottom, 2 minus 8 gives us negative 6, which ultimately results in positive 5/6. That's not going to reduce anymore, but we never want to have a negative on the top and a negative on the bottom. We'd simplify that to positive 5/6. So now we have to compare these two slopes. They are not the same, and they're not opposite reciprocals. So if we were to explain this in a complete sentence, we would say the lines do not have a parallel or perpendicular relationship, because we've proven that with the fact that they aren't the same and they're not opposite reciprocals. The lines do not have a parallel or perpendicular relationship because the slopes are not the same. And are not opposite reciprocals. You know, that's a lot of writing. Typically, I wouldn't make you write this much. Okay, so that is it for the notes on this one. Let me know if you have any questions. I'm hoping that this is somewhat familiar. I know that the parallel perpendicular relationship is probably new, but hopefully finding the slopes of lines and finding equations is something that you somewhat recall back from like Algebra 1. Okay, well, let me know if you have any questions. Please do the follow-up homework and have a